Hello students, myself Amrita Roy. Today we are going to study about the bandwidth and selectivity of a parallel resonance circuit and comparison between series and parallel resonance. So first let us go through the contents. So we are going to study about the bandwidth and selectivity of a parallel resonance circuit and the comparison of series and parallel resonance. Bandwidth. The bandwidth of a parallel resonance circuit is defined in exactly the same way as for the series resonance circuit. The upper and lower cutoff frequencies given as F upper and F lower respectively that denote the half power frequencies, where the power dissipated in the circuit is half of the full power dissipated at the resonant frequency 0.5 I square R, which gives us the minus 3 decibel point at a current value that is equal to 70.7% of its maximum resonant value, that is 0.707 into I square R. So as we know and studied in the previous presentation of parallel resonance circuit, we have seen that the graph has a dynamic impedance at the middle portion, that is at resonance condition, and the graph has a maximum value when the impedance is equal to the resistance. So the 2 points of the graph had two frequencies, one on the left hand side and one on the right hand side of the graph. The left hand side of the graph had the frequency which we call the lower cutoff frequency, which was noted as FL, and on the right hand side of the graph the frequency was called the upper cutoff frequency. So the distance between these two frequencies will give us the bandwidth for a parallel resonance circuit. Now for calculation of power, we know that maximum power will be delivered according to maximum power transfer theorem when it will have a value of half I square R, which will give us a minus 3 decibel value, that is equals to 70.70% of maximum resonant value. So for calculating bandwidth, we are going to use resonant frequency and quality factor as the parameters. So bandwidth can be calculated either by subtracting the upper cutoff frequency minus lower cutoff frequency, or we can calculate bandwidth by dividing quality factor from the resonant frequency, that is Fr divided by Q, or BW will be equals to F upper minus F lower. The selectivity or the Q factor for a parallel resonance circuit is generally defined as the ratio of the circulating branch current to the supply current. So the quality factor can also be calculated by dividing 2 pi FL with the resistance, that is resistance divided by XL, or 2 pi FC into R, that is equals to R into root over of C by L, will give us the quality factor. So if any question is provided to calculate the quality factor and only XL value is given or only XC value is given, we are going to use this formula for calculating the quality factor. And as discussed, quality factor is basically the ratio of the circulating branch current to the supply current. So here I have provided the graph for the bandwidth of a parallel resonance circuit. So we can see that the bandwidth is basically the distance between the lower and the upper cutoff frequency. Now it is cutting the graph at a particular value which is 0.707, that is giving us the minus 3 decibel point, and the maximum peak value has a value of 1. Now the average, that is the output gain, is denoted by AV, which is basically denoted as V out by V in. So this is basically the bandwidth, and the bandwidth can be calculated by subtracting lower cutoff frequency from the upper cutoff frequency. And the mid portion of the graph is basically giving us the resonant value Fr, that is the resonant frequency. Next is the comparison of a series and parallel resonance. So let us go through this. The specification, first one is the impedance at resonance. So for a series resonance circuit, it is maximum, but for a parallel resonance circuit, it is also maximum. Current at resonance for a series resonance circuit is maximum, but for a parallel resonance circuit, it is minimum. The effective impedance is R, but for a parallel resonance, it is L by CR. And a resonance frequency, the value is 1 by root over of 2 pi LC, that is for a series resonance circuit, and for a parallel resonance circuit, it is root over of 1 by 2 pi LC R square L square. Now for magnification, series resonance circuit, it magnifies the voltage, and for parallel resonance circuit, it magnifies the current. Now the series resonance circuit is known as an acceptor circuit, and the parallel resonance circuit is defined as a rejector circuit. And the last factor, that is the power factor for both series and parallel resonance circuit, is unity. So it has some differences, some similarities. So this is basically, this chart is giving us some similarities and some basic differences between a parallel and series resonance circuit. Thank you.